I'm Tony Hand, and I'm the Sustainable Mining Project Manager here in TalTech. And we want to start with looking at the value chain of raw materials. Henry just touched on it there earlier, but the value chain starts with the exploration, where the metal minerals are found. And once the deposit is proved to be viable, the mining begins. And once the material is created, the concentrate or whatever is shipped, and then it goes to smelting into the production of whatever the product is. Substitution is something that is not really spoken about that much, but it is a thing that's happening with a lot of research institutes to see can they substitute some of these critical raw materials by using other safer, more easily found materials. And of course, there we are, we're the end user market. And of course, this is basically where the linear economy works. Then the end user market, it goes, once the thing is finished, it goes to the recycling or landfill once upon a time. But in this case, the value chain ends with the circular economy. And this is where it works. And Henry just mentioned it there, but it's no harm to remind people or keep this image in front of everyone. But the whole idea of the circular economy is to minimize waste and to maximize resource use. And as he said, you can see waste comes out of every step of the way. And the circular economy will work if some of the materials that are put back into the system again, whereas waste from mining, the possibilities of it being used in construction industries or other industries, it creates this more circular economy. So there's no waste sitting on sitting in the environment. Yep. And this, when it comes to the critical raw materials that Henry showed up there earlier, the EU we can see Europe is a very grey spot when it comes to our own supplies. And we can see that for China, for example, supplies most of our critical raw materials. And in particular, you can see the bottom figures there of 99 and 98% of the rare earth elements. We'll talk about them in a moment, but they're broken into light rare earths and heavy rare earths. And I'm not going to take them in that way. We'll just look at them in general. But you can see that almost all of it comes from China. And the next one slide is a more interesting one because it also shows the level of governance within these countries. And we can see that China, again, with all the supplies, all that material, has a low level of governance, which means political stability, government effectiveness, trade policies, all that kind of thing are run by the government itself and not for the good of the people. You can see there at the very low one is the Democratic Republic of Congo, where most of our 60% of our cobalt comes from. And then you look at Chile, for example, which is a medium governance, pretty stable at the best of times. And that's one of the biggest suppliers of copper. So we depend on these regions, whether they're in the southern hemisphere or in Asia. We depend on them so much at the moment. And again, you can see that Europe is a grey area there with very little happening in it. So the issues with supply chains, we know all about geopolitical tensions. This can, happen anytime at all. The supplies can be cut off, or there can be tariffs placed on them, which we hear a lot about since the election in the US, putting tariffs on goods coming in. Again, investment in infrastructure is a big thing. There is insufficient investment in mining infrastructure because initially in the past was always looked at as a risky business and the damage caused. And if companies are going to look for the banks or whatever lending institutions they have to prove that they have a good safety record. They also have to prove they have a good environmental record as well. And the technological challenges, we've seen, the future mine has some really space age stuff, but there a lot more has to be done for the advancement in the mining and processing technologies. So to improve efficiency and to reduce the environmental impact. So it's all well and good. We are here in Europe, in the Northern Hemisphere, and a lot of advancements are being made here. There's quite amazing stuff happening. But as we saw from the people mining, the artisanal miners in the Congo, that's not a balance that we can put up with. If there's a mining operation, they all need to be playing from the same level field, because the technologies we have to spread it. And speaking of spreading, the likes of the COVID-19, that can show how the disruptions to supply chains can happen so easily in an unforeseen way as well. So yeah, I just pulled this from the news site there on Tuesday. Already China's banned exports of gallium and other high-tech materials because of US chip sanctions. And this is what happens. Supply chains can just disrupt on something like this. There were restrictions on exports initially, but China decided they were going to ban these items to the US. And it could easily happen for the EU as well. So the European Green Deal, this is what we're aiming for. The new technologies, these metals and minerals are needed so that the European Union can become the first climate neutral continent by 2050. It's a tough ask, but we have to do it. We have to aim to do it. So the climate neutrality is a big thing. Circular economy is there, of course. Clean industry, and it's not just the extractive industry, it's all industry. It has to be cleaner, has to be more responsible and sustainable. And of course, a healthier environment. And sustainable farming is in there, but it's interesting because it's part and parcel of the land use. And land use is a big issue as well when it comes to mining. And of course, climate justice and fairness. And, if we want people in the Congo to have proper safe working environments and proper safety equipment and then proper extracting equipment and everything like that, then this is part and parcel of the deal as well. So the Green Deal and the Critical Raw Materials Act, there's a lot of words on this, but in general, this is what the Critical Raw Materials Act is going to play a significant role in the supply security, because as we've seen, the supply chains can be easily disrupted. Whereas if we have our own sources within Europe, we know we can have a secure supply. Sustainability, of course, we have to show that mining is sustainable. Actually, mining is not a sustainable activity, because the more we mine, the less we have. These metals and minerals don't grow back. We can't plant them again. So we have to mine in a sustainable fashion, that we're not taking all the good quality material and leaving behind all the other parts that we think are not worth it. So we have to be much more sustainable. Recycling, and again, the substitution of the critical raw materials. Innovation and research, of course. This is where the Act supports all this to try and develop new ways of doing things, cleaner ways of doing things, less environmental impacts. Strategic partnerships, and this is one that we mentioned earlier on, the strategic partnership in the AGEMERA project with the University of Zambia. There's also a lot of EU, there's agreements with a lot of African and South American countries at the moment as part of the Critical Raw Materials Act. And of course, the regulatory frameworks. It has to ensure responsible sourcing and the efficient use of critical raw materials. And then if you want to find out more, you can click on the link at the bottom for the fact sheet. And this is the basics of what the Critical Raw Materials Act is asking us. We have to extract 10% more within the EU. And this can be somewhat problematic because the companies that are mining at the moment aren't necessarily mining the critical raw materials that we need, and the rare earth elements and things like that. So we have new companies developing, or we have some companies diversifying into this area as well. This remains to be seen. And again, an increase of 40% for the processing side of things and 15% for recycling. And this, no more than 65% of the EU's annual needs for these strategic raw materials should come from a single third country. And we're talking about China here. As we've seen, like the rare earth elements, almost 100% comes from China, and we can't rely on them. We have to see if the source is elsewhere. And this is why the EU is seeking trade agreements and things like that abroad with other countries. The Act as well will require development of national exploration. This will put some pressure on national surveys, geological surveys, because they will have to see what they have in their jurisdiction, and they will have to report it to the EU to build up a good database on what materials we have within our own borders. And the whole process to be streamlined and predictable approach to permitting procedures. And this is to speed up the process, because in many cases, and we're talking even the likes of maybe Finland and Sweden, where mining's happening for a long time, and it's seen as very progressive and technologically advanced, but still it can take anything from 10 to 15 to 20 years before a mine opens. And if we want to be carbon neutral by 2050, that means we have to speed up the process. So this will have challenges as well, of course. So the purpose of the Act, basically, it is we have to be ensure that we have a secure and sustainable supply of these raw materials, and it's essential for the EU's economy and the strategic side of things as well. We have to know we have a safe supply. And then the legislation aims to reduce dependency on a single third country supplier, already we mentioned, and to strengthen our own supply chains, and in conjunction with doing it sustainably. And this is it. The EU seeks to enhance its resilience against supply chain disruptions that we've seen can happen so easily, and support its green and digital transitions, which is vital. Again, there's a link to the regulations there also. So the key objectives of the Critical Raw Materials Act, again, it's strengthening the domestic supply chains. We have to boost our own capacities here. We have to find out what we have. We know, as you saw in Henry's picture, there's a lot of metals and minerals that we know are within the EU or within Europe, but to discover how they can be extracted, are they viable, and the technologies used to extract them as well is very important. And then, of course, we're reducing dependencies on other countries. And of course, we have to do it in a sustainable fashion to promote the circular economy. So we'll have a quick look at rare earth elements. As I said, we're not going to break them down into heavy and light. We'll just lump them all in together for the purposes of time. But what are they? And they are a group of 17 chemical elements in the lanthanide group on your periodic table of elements. And they play the crucial role in all these modern technologies and in the energy sector. So again, we see the various high-tech devices that we use every day. They're essential for our mobile phones, our laptops, our TVs, our electric vehicles, or our ordinary vehicles as well. And why are they important? Because we see that more than 200 products rely on operating via rare earth elements. And we see high-tech consumer products. And you can see there, yeah, cellular telephones, computer hard drives, all this. But we've seen, last Friday was Black Friday, so the amount of products that would have been bought with all these elements in them was probably massive. And unfortunately, more and more we have to look at defense applications because we've seen a big jump in how these technologies and these metals and minerals play a huge role in defense applications. And are they rare? No, they're not, believe it or not. They're quite abundant and there's quite a lot of them available. We can see from this slide here that the least rare uh, is cerium, and that's 15,000 times more abundant than gold. And even the rarest of the rare earth elements, thulium, is 125 times more common than gold. So there's a lot of it there. The problem with it is they are not found in one deposit. They're attached to a lot of other metals and minerals. The extraction and the refining involves a lot of energy and water and sophisticated technological processes. Some of them are still being developed. And the processing again is it's a complex procedure. It uses a lot of as I say, energy, water, and chemicals. So the separation process, it's precise, but it's complex and usually expensive. And what are they used for? Well, yeah, so we can see they're used in our everyday things, even someone wouldn't expect, like the ceramics, for example, and the paint pigments. Um, and again, the catalytic converters in our cars and rechargeable batteries. But the main one to the right is the essential for super strong magnets. And the super strong magnets can be, you can see they're used in cell phones, but permanent magnets as well that are used in wind turbines for energy capture and things like that. These are vital. And you can see this is almost two extremes from nuclear power plant to an MRI scan. But the technology here needs these materials because it won't work otherwise. And we can see how we take, if anyone has ever had an MRI scan, you kind of take it for granted that this thing works. But how does it work? Because it's made up of all these metals and minerals. And then, yeah, other everyday objects, rechargeable batteries, screens, microphones, lasers, all the things that are in the photos there are just part and parcel of what they're made up of, these rare earth elements. And as I said, defense applications, which are becoming more and more crucial. You can see that these are used for a lot of, well, not just weaponry, but also tracking, uh, guidance for missiles and things like that. Because the sad thing about a lot of the materials, metals, and minerals that are used in weaponry never get a chance to be recycled because they're generally blown to bits. But for other things like that, lanthanum we can see is night vision goggles, and some of this stuff is used by the general public as well. Again, a few more, your flat screen, X-rays, laptops, fiber optics. Yeah, they're just, things that are in the house, they're beside us. We have them in our pockets, all this. So we rely so much on them, but we don't even think about them. So the environmental considerations when it comes to rare earths, as I said, it's found in low concentrations. And we see mines are often in countries where environmental and social standards are very low. This particular image is from China, and you can see that it's believed that 1 ton of rare earth elements creates around 2,000 tons of waste and partly toxic waste as well. So if this is what the sourcing of our rare earths contributes to, then what we should look to our own and know that we can do it in a far more responsible and sustainable way. And the human considerations as well. People living near mines, water drain off and things like that, they can have a very poor standard of living. a very unhealthy standard of living as well. And we can see that the rare earths can have the benefit of being enriched for fertilizers, particularly the phosphorite. But again, this can contribute to contamination and things if it's not used in the proper way. Battery-related materials, I'll just go through these because these are a different group, but these are important when it comes to electric vehicles and stuff like that. So you can see a number of them there and what they're used for. We're familiar with zinc, aluminium, and copper, but the manganese and the nickels and the lithiums, what actually do they do? And the cobalt, of course, as well, which is becoming a very important material. So supply challenges, as we've seen, again, supply challenges always a thing that supply chains can be held up with bottlenecks. Again, the climate goals, we have to reach these targets, but how do we do it without these minerals and batteries for storage? And the sustainable sourcing, of course, is always what we have to do. And I will actually consider ethical sourcing there as well, because it's part and parcel of ensuring that the people in the regions that they get a fair wage and safe working conditions. Here's an image of your electric vehicle. Of course, these things, lithium and the copper, always important. And the cobalt, of course, you can see the makeup of an electric car battery here, and the materials that are used in it. Again, we see that there's quite a lot of these materials required to ensure that an electric car works. But we can see the global production and consumption, 100,000 metric tons of lithium produced for batteries. What it's like today, not sure, because this whole market for electric vehicles is a bit disrupted at the moment. But this is what an area for lithium brines is from South America. It's pumped up to the surface and then it's left to for the water to evaporate, and the salts that are left behind, the lithium is contained within them. But you can see they're pretty damaging on the environment, the local environment. So we can't allow that to happen. If we find lithium sources within the EU, we have to ensure that it's done in a proper, sustainable and environmentally friendly way. So in summary, responsible sourcing, extracting and processing are vital for Europe. Again, the regulatory frameworks, we have to ensure that they're upheld, that they're the companies work to them, and again, develop more sustainable practices. And like I said, the responsible sourcing, but the ethical practices, and supply chain diversification. Engaging with reliable resource-rich countries to meet growing demand. And again, we have to look at a number of them and not depend on China, because of trade wars, tariffs, all this kind of thing has been in the news recently. So we don't know what can happen, but we have to ensure that we are safe and with a secure and sustainable supply. And the European Critical Raw Materials Act will ensure these priorities are met. So that's a quick run through some of the critical raw materials, rare earths, and the battery-related materials to show that it's not just straightforward. The challenges are there with supply chains, challenges are there with ethical practices, and environmental challenges there as well.